Morning, everybody. Hello. Good morning. Let's start here. Actually, no. I started playing with P5 again last night, avoiding stuff, and you can do some fun stuff with it. Let's see. Pause. Oh, I need to hook this up to some music. That'd be fun. Good morning. Nice. Oh, that's a nice, matches up with the synthwave tunes we got going on here. It gets quite trippy. Alrighty. Let's get into it. So, I'm going to post this either today or tomorrow for your final deliverables. I just want to clean it up a little bit. But I wanted to make you aware that it will go up. I'll throw an announcement up too, just so that you know what's going to be due. Basically, your final project write-up is going to be your software requirement spec that you did for your midterm, about the midterm time. So you're already halfway there if you did pretty well on there, and if I recall, everybody did fine. I'm just going to have a max, like a minimum amount of requirements you'll need to add on to that to flesh things out based on where you're at. Shouldn't be too much of a stretch for you all, I would hope. And I'm going to have you basically add some tables to your software requirement spec. Test cases we'll talk about pretty soon as well. The last 2 days of class will be your presentations. And as I was kind of looking through the calendar here, I think we're going to have to start speed running some of these lectures because I think I'm taking too long this time or something's off, but we're a little bit behind from where we should be. As a note, I might kind of gloss over visitor because we still have test-driven development to get through and object-oriented concerns and things like that. And we have anti-patterns. So I'm probably going to gloss over visitor pattern today a little bit so that we can move forward. But that is where we are at right now. And let's see. No, you log into Blackboard before class and you think it would remember your login. So you also have till the 14th for your MVC implementation. I've already gotten a couple of questions about how complicated does it have to be. Again, I don't care what it looks like. This is not a class for making things stylistic, I suppose. If you want a terminal application, that's absolutely fine. Just make sure that you're implementing the pattern correctly, which is separating out your view and your controller. And your model. Should say that too. So with that, we kind of ended right about here-ish with this MVC, and I started screwing around with Flask and realizing that I forgot what the call was to actually run a Flask server. Because when you teach, your short-term memory just kind of disappears. It's incredible. I swear I'm not this absent-minded in real life. Or maybe I am. But I set up a little simple Flask application. Now, this is not a perfect MVC implementation. but it does kind of give you the idea of how a controller would work. Typically, you would separate things out a little bit more. So let me go ahead and run this now. Python 3, oh, not HTTP server. We just want to run my application here. So I'll run it and then I'll kind of show you what's going on. So you kick off. Okay, development server. I get a local IP, local host, 5000. Server works. I can go to /greet, hello from server. Let's go ahead and add a new route. So let's say app.route. Yeah, let's stick with that. CIS350. Def, hello there. Return, hey there, 350. Hope you have a great weekend. Mate. Now the question is, are you going to auto refresh for me or not? CIS350. Nope. Okay, I have to rerun. There we go. So kind of the point here, not to, well, Flask is something that's cool if you want to run a little web server in Python. But this, if I were to abstract this out a little bit more, would be a great MVC implementation. So here are these routes. These would be my controllers. I am routing you to different aspects of my website, right? So if you go to the homepage, your index.html, if you're, a web developer, this would be one route where I would return the homepage view. If I route to 350, I would instantiate the view for the 350 specific things. And I would probably have a separate class file or, a separate file that I'd be pulling in here where the view renders everything. And same for greet here, different route, different page, different view. And again, here, this is not a perfect implementation, but I could talk to my database from the controller, and I could say database.get CIS350, and it would return whatever information needs to be passed there. The controller would talk to the view or talk to the model. Model would return some data. I would pass that to the view. Depending on your implementation, the view can directly talk to the model as well. If it is a simple call, if we have a lot of moving parts, you want your controller to be in charge of things. But depending on your, again, complexity of your application, maybe your view can get by just talking straight to the model. But the notion hopefully makes sense, right? We're separating things out, separating out our concerns. In this UML diagram that you see here, and we can go into presentation mode now, you see that we have separated out, we have a main, we have a controller, we have a model, we have a model, we have a view, we have a view interface. Sorry, we have a model interface too. But all of these are very clearly separated. Again, we have a very loose, well, not loose coupling, but we have nicely separated out concerns, meaning that if I want to work on my view, here you see some buttons, you see references to the controller in the model. I could add buttons, I could add text boxes, I could do whatever I want. It's not going to hurt the controller or the model. If this was all one big class, everything would need to be updated. That's the whole purpose of MVC. I did shut off Flask, right? Okay, good. Should mention, I don't know if this is helpful for any of you. If any of you are budding web developers, let's see, I want to be in my other one here. You can run a local Python web server directly from the terminal. No need to install WAMP or MAMP or a LAMP stack. I could just do Python http.server, and then I get a local web server. No PHP or anything like that, but I basically have a local server instance if I needed one. Say you need to host files and your application doesn't do anything. Yeah, bit of an aside. I just get a kick out of playing with Python. Thought you all might like that too. So we have MVC. We know how to run a local web server with Python, which is cool too. Let's talk about MVP, and then we will skim over visitor and start talking anti-patterns. Again, today's a bit of a speed run. MVP is very similar to MVC, and depending on what you wish to accomplish and what you wish to achieve, you would pick one or the other. This is, again, separating out the model and the view, but you don't see a controller here. We see a presenter, which is kind of a controller-ish or a controller light. So this is another architectural pattern. It's another decoupling type of pattern. But here, the controller is basically kind of it's not as present, I suppose. So we basically want to decouple the business logic with the GUI is what we're getting at here. The model is going to, again, be in charge of your data. The presenter is kind of in between. Again, so the controller in MVC, it's in charge of routing, it's in charge of slinging data from the model to the view. Here, the view really only shows data, whereas in MVC, the view could be a little bit more powerful, if that makes sense. So the view can handle quick events and tell the controller this happened. Here we are just putting like a tiny shell of a view out there. The presenter in this case, which is the controller replacement now, this is where we have the majority of our logic for our program. Okay, whereas in MVC, it's kind of more evenly distributed. Here, the presenter kind of takes on what the view did in the other side of things. So let me go back a little bit here. So the view renders a model, requests updates from model, sends gestures to controller, allows controller to select view. You see there's a lot more responsibilities with the view for MVC. If we go to MVP now, the view is our basic view is basically just going to act as a container for visualization. That's pretty much it. The presenter is going to handle the user inputs, user gestures, routing, model, requesting, things of that nature. I don't have a demo for MVP, but you can kind of get a feeling for what the differences are here. So MVC, let's say we start with our controller, right? And we render a default view. We see that the user clicks go to 350. Okay, controller is going to ask the model for information, update the user interface, render the view, right? This is what we saw last time and a little bit with Flask there. Here we also see that we can have a connection from our model to our view right here. So let's say that our string for 350 changes from hello there to good morning, have a great weekend, or something like that. Well, if the view is currently rendering that from the model, we don't necessarily need to talk to the controller for that. Now we can, if we want to, right? We can update the model, change the model, route data from the model to the controller to the view, or we can directly do that. Here, we kind of see less of a connection with our view to the rest of the system. Okay, so we still see model change to update model, update UI user actions, but we don't see a deep connection here. And where I said a few minutes ago that, the view is basically going to be very, very passive and a thin shell. Let's say that I render some buttons, some checkboxes, stuff on the screen for the user to click. Well, here in the view, rather than implementing any logic, I would just simply pass like button 1 clicked, or fire a callback event in the presenter here that this thing was clicked. Whereas before, maybe if I click, let's say we have a refresh button, I suppose, or yeah, a little refresh button to update your current page. Here, I could click refresh and the model would directly send me data. Here, if I click refresh, I have to go through the presenter, check the model, get the data updates, update the view. So basically, this is a lot less present, is a way to think about it. Now, I've got some extra links here if you are interested in implementing any of these yourself in Python. I would say that if you want to pick a pattern, it's kind of dependent on your kind of your background and your interest and what you want to work on, what you want to work on, I suppose. I thought there was a slide here. Where did you go? Okay. Regardless, excuse me. There is kind of a debate on the internet which one is better, MVC or MVP. There are people who absolutely love MVP. There are people who absolutely love MVC. I would say that they're both fine. They both do very similar things. There's not a whole lot of difference architecturally, right? They're still doing the same job. It just depends on how intertwined you want your view to your model, basically, how much responsibility the view needs to have. And I would say that at least on the internet with a lot of the packages out there, you tend to see MVC a lot more, right? If you're doing MVP, it's probably because a package or a framework or a product that you're using specifically wanted to do MVP because everything is MVC, and you probably have seen MVC in some of your, some of your various like modules that you've had to pull down or run with, maybe for various classes. Kind of like I mentioned, CodeIgniter is pure MVC. Anything that you want to, again, separate out those concerns is where you would go with that. So that's MVC and MVP. You should be set for the homework now if um, if you caught that last time. Oh, I did finally put up the code. Coffee hasn't kicked in yet. Apologies. So design pattern code sample. So this is all in Python, by the way, and it's all Python 3. But I've got MVC, visitor, observer, singleton, facade all up here. If you want the Java code, check the slides because I haven't actually I basically run it as a class file, but I have run them in the past. I know that they work. And if you don't like them, they're from Professor DeVries, who is the Java expert. You can yell at him if his code doesn't work. But you can run it in Eclipse or something like that, and it works just fine. But MVC through Facade, all up there. Now, let's see. Somebody stop me if we hit 9:30 and I'm still talking about visitor. I just want to kind of quickly go through this one. Because visitor is an interesting one. If I was mean, I would make you implement this. And I'm not totally mean, so I'm not going to make you implement it. You're doing MVC instead. But this one can be kind of tricky. It's pretty cool, though, in terms of the class. And basically what visitor gets you is if you have a class and you're not allowed to update it or change it, right? So maybe you have received this class from another package, you're importing it from another class file, and you can't actually touch it, right? You can't add that field that you need, or you can't add a function call that you need, but you still need to update it, right? You still need to work with this class. Visitor gets you the ability to change things remotely. So this is a behavioral pattern. Hopefully you got that from my little description there. We are going to be changing things at runtime. So let's pop this all up in here. Basically what we want to do is add a visit function call. So we want the ability to update a static data structure. And we're going to handle that by kind of doing some object-oriented trickery to allow a class to be bent to our whims, which is kind of fun to say. Makes you sound like an evil genius. The way to kind of visualize this is, let's say that you're pulling down a package, right? So you have a library that you've pulled down, and you need to use it in a way unanticipated by the framework developer, the module developer. Well, we can wrap this in a visitor pattern, and we can extremely extend it to our whims. So reference to 2000s era Flash game. Anybody ever play this one? It was kind of gory. It was like if I recall, it was like a worm that just kept growing based on the actions that you did, or it would horribly kill you as you did things wrong. One of those like Newgrounds era games. But How do we implement this? Every data structure is going to get a visitor class. The element types have an operation that are going to be defined by that visitor that we have added on. So we can add new operations really easily. We can add things on pretty easily. We separate our concerns pretty easily. Let me go into an example here to maybe help explain this. One of the issues that happens here, though, is that we break encapsulation. So if we have a class where it's very neatly constructed, like say it's the perfect class, we're going to break that perfection and open it up to the world, is what's happening here. So what are we going to do here? Again, I'm kind of going through this quickly. Let's say, again, that you have imported a class, it's fixed. We're going to now separate out its algorithm. And we get something that looks kind of like this. And this is probably not super great to just understand at the outset. So I pulled this off of the Geeks for Geeks website, which is kind of a great little blog slash technical blog for explaining a lot of these things. I've got the link hidden there under my taskbar. There it is. But what we have here are we're going to have elements, we're going to have concrete elements, we're going to have visitors and concrete visitors. Now, what are these actually going to be? So element and, sorry, that's the visitable. Here's our client, here's our client, here's our visitor, concrete, concrete. Basically, the client's going to be our consumer. So this is the thing that we're actually going to be, having to deal with here. We can, via the client's class, tell our data structure to accept a visitor. And what this visitor is, it's just something that gets passed in that's going to be executed somewhat blindly. Right? So again, this is behavioral. We're kind of trusting that our algorithm is going to do something correct here. Okay, well, this client's going to talk to the structure of the object, and we're going to have an element. This is where we're going to accept some visitor. Okay, and the visitor is this extra functionality that you're adding in, this extra function call. And depending on what you have class-wise here, we could have multiple concrete instantiations of a particular class. So concrete element versus element. This is basically the specific instantiation of this particular thing. We're going to make sure that each of them can accept a visitor. And this visitor is basically going to be kind of like a generic object that we pass in. Okay, so let's say that we are able to add this visitor on. Well, what a visitor does is it can visit. So here we have the visitor. It's being accepted. We're going to create this visitor class and have it go visit all of these elements. And what could we be doing here? Maybe we're passing on different algorithms. So instead of, let's say that we have an element class here where we have a list of objects inside of it. So this could be our game manager. We have a list of, I don't know, NPCs or something like that. List of characters that are walking around our game. Well, I could pass on a visitor to have them all update themselves, for instance. So maybe I'm going to pass in a visitor to say, update your current mood. And if we're doing something, I don't know, Dwarf Fortressy, so for some reason I was looking at Dwarf Fortress stuff this morning. My dwarves, some of them get mad, some of them are happy, some of them feel poetic. If any of you have ever tried or looked at Dwarf Fortress, you realize that the dwarves' moods can vary wildly from minute to minute. But we're passing in behaviors here. Effectively, what's going on is we're doing something called double dispatching here, where we have a visitor being passed in by itself, which is kind of an interesting thing to think of. So let me let's see. I've got an example which can help with this. I'll show you that to you in a moment. Client's going to be our consumer. Our visitor is abstract. We're going to declare future operations. The concrete visitor is going to actually implement those. So the other thing here too, this is a generic abstract class. these are going to be specific actions that we want to visit upon this class. I hope I'm not talking in circles too much here, but it's a tricky concept. Basically, we're passing in different behaviors via these concrete instantiations. So let me give you an example here. This is a way to figure out professors and students and classes and figure out who is responsible for what in this particular situation. So we're going to have classes for, I'm going to use courses. So let's say we have 3 courses here. STE, DSA, STL, this could be CIS, whatever the other acronyms are for colleges at our university here. CIS, IS, M, cybersecurity, sure. Well, let's figure out who is instructing what. Let's figure out who is attending what, or maybe who's registered for what. We basically can kind of define abstract classes for people and for courses and then figure out who's doing what. So let's take a quick peek at this. And again, this visitor is from Geeks for Geeks. I put the code up in Blackboard. Oh, I also have a nice little flower one too, so we'll check that out as well. All right, so let's go to our main here. I don't have a main. So I'm gonna create concrete objects here. So SDE, STL, DSA, these were our courses here. I'm also gonna create an instructor and a student. So these are our visitors. Okay, so concrete class, which would be your elements from the figure, our visitors. So we're gonna let our people visit these classes. And then these object classes here, right, these concrete classes will have an accept function. So that's going to be a generic call here, where regardless, I'm going to accept an instructor, I'm going to accept a student. Right here, when I'm creating these visitors, I would have, say, 1 instructor and then 30 to 60 of you, right? So it'd be a list of students that are going to visit. Now, the course object itself doesn't care. Okay, that's the key here. And this is where things get a little bit different. I'm going to accept an object regardless of what it does. And this is that whole breaking encapsulation thing. We're going to just let a class come in and do its thing. So if I go ahead and run this, let me show you what's going on here. Visitor. Thank you. SDE is taught by an instructor, studied by student, taught by instructor, studied by student. Right? So we actually see, sorry, the font's a little bit tiny there. I forgot to increase the size. But when we print out who is responsible for what, it's actually saying the correct thing, right? It's not saying SDE taught by student, studied by instructor. So what do these classes actually look like? Well, this is getting into a little bit of object-oriented trickery again. Let's say that we have a controlling course here. We're going to say that this class has an accept function, a teaching function, and a studying function. For accept, we're going to accept some visitor. Teaching, we're going to accept a visitor. Studying, we're going to accept a visitor. When we accept something, we're going to call the visit function. And what this visit function is, or sorry, this visit object is, we define that later on. So let me skip down a little bit. We now have our concrete visitors, where each of these implements a visit function. And instead of, and what we can do in here basically is define the exact behavior that we want. So instructors teach, students study. What is studying? Well, here we have teaching, studying. Taught by, studied by, so that's what you saw in the output. And we've got some, kind of Python-y type things. Let's stringify our classes so that we can just print it out. So I could do print courses at GFG, and it would return the class name. Again, it is a little bit abstract in how we define things, but we're really leveraging our object-oriented procedures here for passing in abstract behaviors. Right? I could very easily add on, I don't know, let's say somebody who is auditing a class here. right? So I would define an auditing function for a generic course. I would have it pass accept a visitor, and I could say, you know what, let's try that just to see if I break things. Def auditing, because then you're going to take a class without actually paying for it, right? Print self, you get a freebie visitor. So we've defined a visitor here, a new visit function. Courses are going to stay the same. Visitor stays the same. We now need a class auditor. It extends the visitor. Def visit self. I don't know why we call it crop, but crop.auditing self. So basically, I'm now adding on a third entity. And now let's create auditor equals auditor. So now I've created a new person. And let's say just SDE can accept this auditor. You can see how quickly I spun that up, right? And now, how would you do this typically? Well, okay, let's have a generic course with an instructor field, a list of students field. But here we have broken everything up nicely, right? There's a lot of separation at the cost of being a lot more complex. Let's clear this out. Python, did I break it? I did. Oh, come on. Python indenting. Yeah, that's not surprising. Line 75. All right, so let's get rid of these. Copy these because my is this gonna work? Okay, there we go. It didn't like my tabs versus spaces, I think. But what we see here, there's my new line. Again, what did I do? I just added on a new visitor. I didn't do a whole lot of complicated stuff. The framework is already there for me to just add new features easily. And that's in Python. You get very similar behaviors in Java. I've got a link here for a Java example if you want to play with it. Basically, let's see. The implementation is going to look pretty similar. We're going to have, some object-oriented stuff going on here with extending our various classes, accepting a visitor. Here we're processing JSON versus XML. So if you want to play with it in Java, check out that site. It's pretty good for walking you through the Java aspect. But advantages here and disadvantages, and then we'll move on to anti-patterns. We can add new behaviors very easily once you get that framework up and running. And it's going to be generic, meaning that if you are giving this capability, you should be very careful with what you do with it because you're basically adding a generic operation on. But it can be difficult to understand. It's very complex. If we change an underlying class, every single visitor has to be updated as well. And again, it can be quite complicated. That last point that I made about having to update everything. Let's say that I update what a course is defined as. All right, so maybe it's not just taught by, audited by, studied by. Maybe, I add on a course number. Maybe I add on a cost per credit hour. I'm going to now have to go and update every single visitor to handle that. So it can be kind of tricky, I suppose. All right, so we're going to skip the in-class assignment so that we can move on to anti-patterns. But visitor makes sense more or less. Kind of the purpose of these design patterns, at least from my perspective, is not necessarily how to implement them, but why you would use them. So if we're good, give me a thumbs up or a F or something, and I will move on. Nope, time for self-study. Is that a positive or a negative? Basic, maybe both. Could be. There are a ton of patterns. Okay, there is more than the 23 that we talked about on day one. There are a lot out there. They are all very well understood for how to implement them. There is boilerplate code out there to go and grab if you want to add these into a project. The important thing is why you would use them. Okay, so let's do a quick review and then we'll talk about anti-patterns and then we'll end for today. So I'm not going to ask you this, we'll just kind of run through this. Singletons when you want a single instance of something in memory, right? You can have copies, you can technically update it, but you would use a singleton when you want one cohesive memory object, right? We talked about that in great detail. Oh, I left the sliders in from last time. Facade we talked about too. This is where you want a common interface, right? You want to hide the things behind the scenes. It gives you a lot of flexibility with handling updates. The client only sees the facade. Your developers, front-end developers only see the facade. Maybe you, the back-end developer, have all your complicated workings behind the scenes. And you can add them, subtract classes, update behaviors, as long as your facade still is usable. Observer. We're going to use that when we have an object that we need to keep an eye on. So let's say that we have our cup of coffee. Our cup of coffee is just about empty. Maybe I notify my coffee machine to start brewing another pot. Again, here we've kind of flipped the paradigm on its head where now we have something that can go through state changes. Once that state changes, notify everybody that's observing you, right? Notify all the observers. They can then take the appropriate action based on what the current state is. This is again, let's say that this is your video game option, right? We have, let's pick on the checkers team. Okay, so we are monitoring, let's say we're monitoring the current piece that is being moved around the board. And we could say it is being observed. So I move it around my board, I take down 5 or 6 enemy pieces. I could then notify the game state that I have moved to a new location, and B, that I have taken all of these checkers along the way. Notify the game logic that my score has now increased or that I need to be kinged or something like that. But useful when you have a one-to-many type of relationship. Visitor we just talked about. This is going to be when you want to add on behaviors to a class. So you want it to just accept some generic operation and then you go ahead and execute it. MVC and MVP, we have nice separation of concerns. You have your data model, you have your view, you have a controller. I need a third hand for that. MVC or MVP just depends on how much power you want your view to have. That's really why you'd pick one versus the other here. Remember, MVP, this passive view, or the view in general here for MVP, just a shell, it's just a husk, it's just showing you data and routing quick events back to your presenter here. Whereas in MVC, view has a little bit more power. Okay. So, let's talk anti-patterns for the next 10 minutes, because I think this is a very important topic for you all to get. Again, the design patterns are very useful and very helpful, but there are a lot of them, and we could spend days on patterns. Anti-patterns are kind of fun though. So this is a wiki page for all of the anti-patterns that are out there. And if you look at this, and I'd recommend you do just for fun, these are all of the things that you should avoid when programming. So with design patterns, we identify all the common principles, we identify what's important to do in your code, right? These are common issues that we solve. Anti-patterns, these are all the common pitfalls that developers fall into. We also have them for project management too. So let me zoom in a little bit. We see analysis paralysis. We see design by committee. We see groupthink, micromanagement, seagull management. Ooh, this is a fun one. Management in which managers only interact with employees when a problem arises, when they fly in, make a lot of noise, dump on everyone, do not solve the problem, then fly out. I can guarantee at some point in your career you'll see a manager like this. But what is this site all about? Oops, you go over here, you go over here. These are anti-patterns. These are things to avoid. And it's not just organizational, it's also programming wise too. So let's talk about some of these things. Right, they're all listed here as well. So big ball of mud, input kludge, race hazards, circular dependencies, God object, object cesspool. These all have names, basically. All of the things that you should not do, they have names. And people keep finding them. So let's start with the God object. This is probably one of the most common anti-patterns that you can fall into. It means that your object or your class is God. It basically does everything. You know, this is what you do is probably your first to fifth Java projects where you just put everything inside of a single class, right? It's easy because it's in one file. Basically, you see something like this, and you see a massive class that really needs to be broken up. We need to separate out our concerns. Okay, so we don't have the notion of a single responsibility principle being followed. What your classes should be doing, and we'll talk about this when we get into object-oriented programming next time. Every class should really have one purpose: to be elegant and to separate things out, I suppose. Realistically, that's never going to be the case, right? But ideally, every class that you write does one thing and it does one thing well. So if you see a class like this, where we're managing all of our employees, hire, terminate, edit, add vacation time, add address, give bonus, dock pay, add phone number, this should be separated out significantly. And the reason why this is a problem is that if I have to make an update to this thing, I'm probably going to have to update every single aspect of this particular class. These anti-patterns go hand in hand with that idea of technical debt that I kind of brought up last time, where if I kind of fudge something or I make a fix quickly or I follow, I kind of get loaded down with this sunk cost fallacy of I've already spent all this time developing this class, let's just keep doing it. You can very easily extrapolate how long it's going to take to fix later on, basically. So, God object, don't do this. Another fun one, the big ball of mud. This is where you have a very poorly constructed project. This is where you have no idea why something is the way it is. You have no idea why there are interactions that shouldn't be there. You have bad data hiding principles like why is this private? Why is this protected? Why is this public? Doesn't make any sense. Lots of spaghetti code. Maybe there's lots of duplicate things in there. So I've got two classes that are doing the same thing. Maybe they were developed by two separate people and we just added it into our code base because that was their job. But you get something like this when you have kind of poor project oversight. Hopefully it makes sense why duplicate attributes would be a bad thing, right? Let's say that I've got 3 different classes that represent a person in my system, and they each have their own social security number field or their own password field or something like that. If somebody makes a typo in one, it's not going to exist in the other. And, basically you just get a big, messy, horrible ball of code. Hopefully you can kind of get at where things like this can happen, and these do happen in the real world, just as a forewarning. We also have the law of the instrument. So this is where you have a thing that you absolutely love to program, and you're going to use it for everything. So this is your silver bullet. It's your golden hammer. It is the algorithm or the design pattern or the thing which you know how to program and you know how to do it very well. And you're going to use it whether it makes sense or not. So I have a horrible example of this from real life because this is what I do. I like writing genetic algorithms. I think they're lots of fun. I apply them to every single one of my research problems that I have because I like them. Doesn't mean that they make sense every time. It doesn't mean that it's the right answer. They can be very slow. They might not find the correct solution. There's better solutions out there. But I like them, so I'm going to use it. This is actually an anti-pattern where you get stuck in a comfort zone. Maybe for a particular problem, it makes more sense to use, like a gradient descent or some kind of a mathematical operation where you can very quickly converge to a solution. Or maybe you're a web developer and you use MVC over and over and over and over again because you really like it. Does it make sense for a single page basic, I don't know, Firebase application where you're just showing some simple data? Probably not. It's way overcomplicating things. We also have cargo cult programming, which is lots of fun. Basically, we are going to follow some magic process where we have no idea what we're doing. We're just going to implement it and pray that it works. So you don't understand an issue. You don't understand the architecture. You don't understand the bug. I'm just going to follow some mystical design pattern that solves this problem. I don't know why. I'm just going to go ahead and do it. This is called cargo cult because this is relating to the cargo cults from World War II. Basically, natives would build runways on some of the the Pacific islands to summon the airplanes that landed during World War II and brought supplies and people and things like that. But you're following some ritual and you don't know what you're doing. It's kind of bad to have a project where you don't understand the inner mechanics of it. Right? Think of all these machine learning models that are out there where we have no idea why they're making these decisions, but we're just going to go ahead and let them keep going. All right, this is a fun one too. We have dependency hell. Those of you that are NPM developers probably have seen this kind of thing before, or JavaScript developers where you're bringing in NPM libraries. We have just a ton of dependencies. And these are class diagrams that you see here, by the way. These are all the visualizations of classes and how they interrelate with each other. Okay? Why is this a problem? Well, size of your dependency packages, for one, all the libraries you're importing. Maybe we have version mismatches. If you're a Android developer, you probably have a appreciation for dependency bugs and frustrations, I suppose NPM as well. But this becomes a problem, right? Maybe we don't need so many packages. Maybe we don't need so many modules. It's possible we have a lot of interdependencies between classes that could be removed. All right, so that is Antipatterns. And again, I would strongly recommend checking out this Wikipedia page because it is just eye-opening if you have never like gone into industry before. This is a fun one, magic strings. So you probably have heard of magic numbers before, where you are working on a project and you just start adding in like n equals 5, seed equals 247, frequency equals 2. Well, why are you setting that to those numbers? I don't know. It makes it look good. It makes it work. The problem with stuff like that is that you're going to forget in a week why you set those numbers to be why they were. Your coworkers, your collaborators are going to have no idea what the purpose of these things are. Basically, it's unexplained. Copy and paste programming. So this could be the Stack Overflow style of programming, right? All of these lead towards problems that you're going to have to deal with later on. And that's the notion of technical debt. That's why we have normal design patterns to try and avoid these anti-patterns. Right, let's take a look at this one really quickly here, the God object. Pretend we're making a massive web application. Right, we're making an Amazon storefront, we're doing a Home Depot storefront, you're reworking the Grand Valley website, whatever it is, you're making a big web application. You as the first-time developer, let's say we're doing it in a Spring Boot application since it's in Java here, we just make it a single class. Okay, well, what if you want to update the School of Computing webpage? Do I have to update every single other web page in here too because I've made one change to its style? Or do I just update the view for that particular site? Anyway, any questions from today? I know I skipped through visitor pretty quickly, but I wanted to get through the rest of design patterns. Questions at all? Should have, let's do take 2 here. I hope you'll have a nice weekend. Smooth fade. Let me know if you have questions on the MVC homework as well. Hopefully it's pretty straightforward to implement, but it should be fun. We'll pick up next week with basic object-oriented programming ideas and kind of the software engineering behind it and how you can get to these design patterns. And then we'll talk test-driven development. It will be lots of fun, and you get to watch me flail horribly at Java. So, hope you have a great weekend. See you all Monday. Give you a party parrot for the weekend. All right. Bye, everybody. Office hours in 10 if you need help.